Oh, good evening. So, I hope you guys were able to remember that we did about arcanones, and now we're moving to topic 8, which is the alkanoic acids. So, I'm glad to have you here. Let us now begin. Normally, what are the alkanoic acids? So, just the same as these are also known as the uh, uh, I was trying to say the carboxylic acids, not the organic acids. They are also known as the carboxylic acids. So the functional group of organic acids is just the same as only that they have what you call as the carboxyl group. So the functional group of the organic acids is the carboxyl group. It is the COOH as the carboxyl group. So all organic acids ends with the COOH as their functional group, and it is known as the carboxyl group. So they may ask to say name the functional group of organic acids. So you have to be able to say it's the carboxyl group, and is the double OH at that. Nomenclature of organic acids. How do we name the organic acids? Normally, all organic compounds like arganones, organic acids. All these are named after their parent, alkanes. So we remove the E from alkanes, then we replace it with the oic. So you can make and then add the term acid, so we can make alkanoic like that. Okay. So we can see some of the organic acids. So we start with number one, which is the methanoic acids. The same as when I was in methana, propana, butana, pentana. So here also have the same thing as the methanoic acid, ethanoic acid, propanoic acid. 6 for hexanoic, 7 heptanoic, 10 for octanoic acid, 9 is for nanoic acid, and 10 is the decanoic acids. Right. Now let's look into the general formula of organic acids. Normally, the general formula for organic acids is CnH2n plus 1, COOH as the functional group, where N is the number of carbons. So if it's a methanoic acid, you put 1. If it's ethanoic acid, you put 2. So where there is N, you put 2. So it's just a matter of substituting. 2 times 2 plus 1, get almost 5. So example here say what is the molecular formula of the organic acids when N equals 2. I mean when N is equal to 6. So it means you put where there is N in the general formula, you put 6. So if N is equal to 6, then C where there is N, you put 6. 2 times where there is N, you put 6 again. 2 times N plus 1. And COOH, so you get almost C6, 2 times 6, 12 plus 1, 13. So you get C6, H13, COOH. That would be the molecular formula of that organic acid. Right? You can add more molecular formulas using that general formula, so nothing else. So you can have these ones as the methanoic acid, ethanoic acid, propanoic acid, butanoic acid, butanoic acid. Simple, they're just using the same formula, right? Simple. Structure, the same thing. So you also draw a carbon. This is the methanoic acid, so it has got 1 carbon. So I put 1 carbon, actually it has got a double bond somewhere. So I put a double bond here. Then 1 hydrogen and the other one is OH. This one has got 2 carbon, so you draw two carbons, 1 and 2, 1, 2, then result will a functional group. We always can double bond, find functional group. So I'm can CO we can the double bond, CO, I mean, just memorize a good as long as I mean functional group. But CO we can double bond. So here, you check the same. So it's functional group, so it's a C double bond, the other bond for other OH. Okay, now we'll just put the hard. The same as there. So go and until you finish the whole table like this one. You got the same. The secreto the same as the alkanoic acids. The same as alkanones or alkanas, the same as because this represents number of carbons, this bond. And when you talk, if you make two bonds, it means two carbons, that means alkanoic acid. That means the alkanoic acids, methyl carbons. Okay, fine. So they go like that. Okay. Let's talk about the sources of alkanoic acids. Normally, you can make alkanoic acids from citrus fruits. Some fruits like oranges, lemons, or citric acids. They have got those kind of acids. Sour milk also some contains some alkanoic acids. Vinegar and human sweet contains alkanoic acids. So these are some of the natural sources of alkanoic acids. So this is the most important part, which is the preparation of alkanoic acids. How do they get prepared? So this is the examination part. You have to watch and then follow properly. Normally, alkanoic acids are prepared by oxidation of alkanones. That's what we learned. So they are. You have to use the alkanones, and then you oxidize them. You change them into alkanoic acids. So what happens is that we use oxidizing agents. I hope you know them, the oxidizing agents. We use the first one is the acidified potassium dichromate 6, and the other one is the acidified potassium permanganate 7. These are the oxidizing agents that we use. So we use the oxidizing agents. So what happens is that it happens as follows. Number one, an alkano is oxidized in the presence of the oxidizing agents and the oxygen from oxidizing agent. And that alkano is oxidized into ethana. Into alkana. Example, ethanol being oxidized into ethana. Then this ethana is further oxidized into alkanoic acids. That's what happens. So number one is that an alkano is first oxidized under the presence of oxidizing agents into alkana. That alkana formed is further oxidized into alkanoic acid. For example, ethanol plus oxidizing agents into ethana. Then ethana, further oxidation of ethana gives you ethanoic acids, like that. So let me just see the equations. So the point is that the oxidation of alkanos to alkanoic acids. First, alkano is oxidized to alkana as follows. So you write the equation, you say, okay, ethanol plus oxygen and the presence of acidified potassium dichromate 6 as the oxidizing agent, they will give you an ethanol and water. So just write an ethanol using its formula plus this oxygen from oxidizing agent, of which its rule is to oxidize the reaction under this acidified potassium dichromate to give you an ethanol plus water. further oxidation of this ethanol can give you alkanoic acid. So then alkana is further oxidized to alkanoic acid. So it means ethanol plus oxygen can give you ethanoic acid under the presence of acidified potassium dichromate 6. Simple as that. So these are examinable areas. They ask you to say with an aid of equations, describe the oxidation of alkanoic acids. I mean the oxidation of alkanols into alkanoic acids. So I have to write as the way I have written here. Right? Then the next will be properties of alkanoic acids. So since we have seen too much, I think I can just stop at this point. But tomorrow I'll talk about these physical properties of alkanoic acids. That will be tomorrow.